Hello everyone. I would like to discuss the properties of kites, including the definition, and then after taking a look at that, just want to do one quick example of using one of these properties. So a kite is quadrilateral, and then let's start with the definition. So it's a quadrilateral that has two pairs of what we say are consecutive congruent sides. So it's a quadrilateral with two pairs of congruent consecutive sides. So what I mean by that is the consecutive sides are two sides in a row that are the same length. And then the other adjacent side, they're not the same. So opposite sides aren't congruent. So in our picture here, the two sides in a row right next to each other, so AD and AB, those two are congruent to each other. And then the other pair, these are congruent to each other. But if we look at the opposite sides, they're not the same. So this means that AB is congruent to AD, and it means that BC is congruent to CD. So two pairs, congruent, consecutive sides. Okay, now there are a couple theorems about kites that give us some properties. So the first is the kite diagonal theorem. So this theorem says that if it is a kite, then the diagonals are perpendicular. So if I draw the diagonals here, so we got the one from A to C, and then we got the diagonal from B to D. So these are perpendicular to each other. So they form the right angle theorem, or they form a right angle. So this says that AC is perpendicular to BD. That's a pretty straightforward theorem to justify just using some congruent triangles. It's easy to get sort of the big triangle on top here is congruent to the big triangle on bottom, just with side, side, side. And then from there we can show that these angles have to be the same as well, so they're perpendicular. All right, and then the second theorem, the second property, is the kite opposite angle theorem. So in a parallelogram, we know that both pairs of opposite sides are congruent to each other. But in a kite, we only have one pair of opposite angles. So these two angles, the two angles that are in between the two sides that are different lengths, so in between these two segments and then these two segments, those angles are congruent to each other. So one pair congruent angles. So we have angle B is congruent to angle D. And the other pair of angles, AC and C, angle A and angle C, those are not congruent to each other. However, there is one additional property, not necessarily a theorem. If we proved it, we could make it a theorem, but just a little side note here, that other diagonal, the one that goes between the non-congruent angles, that actually bisects those two angles. So I'm going to say one diagonal bisects opposite angles. And that does come right from the congruent triangles as well. So this diagonal AC, it takes angle A and it cuts it in half here and here. And it takes angle C and cuts it in half as well. Now that theorem, that property, not used quite as often, but it is something else interesting about kites. Okay, so now that we have a couple properties here, especially the ones about the angles, let's take a look at one example just putting that to use. All right, so I have a kite. I know it's a kite based on the markings, and I want to find the measure of angle C. Based on that theorem we just talked about, I know that this one pair of angles, these have to be congruent to each other. They have to be the same, right? The angles that are in between the two sides that aren't the same. So if I call this one x, this angle also has to be x. Altogether, in a quadrilateral, I know that the angles have to add up to 360. So if I take 80, and then the 50, and then our two angles that are the same, altogether that has to be 360. So let's see what we end up with. 80 and 50, that is 130. X and x is 2x. Subtracting 130 from both sides, we get 2x is equal to 230. And then dividing that by 2, we get a value of x is 115. So that means that angle C is 115 degrees, as well as angle A. But there we go. So using the property, even though we were missing two angles, we could find out both of them.